Imagine we could just blow dust into the sky, or use the ocean as a mirror to cool the planet. What if we could just turn down the planet's heating and cool down the Earth with some clever science?
There's no doubt whatsoever that humans could artificially cool the planet.
Are these delusions of grandeur or realistic proposals? Here are 3 mind-blowing ideas for ways we could potentially change the climate. Let's talk about solar radiation modification or solar geoengineering. Let's start with why it's so hot in here in the first place. The sun is constantly throwing solar radiation at the Earth. It's our primary source of heat. The Earth's surface and the clouds reflect some of it, but some heat is retained. Man-made emissions of greenhouse gases intensify this effect. The result? Global warming.
The reason that the world is warming up from long-lived greenhouse gases is they make it harder for the Earth to radiate away heat. And so you can partly bring the Earth back into balance by reducing the amount of sunlight that's absorbed.
This is Harvard professor David Keith. He's researching how to modify solar radiation in the atmosphere. So how exactly does it work? Let's take a leaf out of Nature's book. In 1991, media reported about the Pinatubo volcano eruption in the Philippines. It was the second largest eruption in the century and emitted huge amounts of ash and gases miles into the stratosphere, kilometers above the Earth's surface. Scientists found out that this event cooled down the planet by about ½ degree Celsius in the following months. Tiny particles called aerosols reflected the sunlight back into space. That leads us to the first type of solar geoengineering: stratospheric aerosol injection. It sounds complicated, but essentially it just entails copying the volcano mechanism. The stratosphere is part of the atmosphere and located between 15 and 50 kilometers from the Earth's surface above most clouds. The ozone layer is located here too. One idea scientists have suggested: injecting sulfate aerosols into the stratosphere. There, the sulfate aerosols combined with water droplets reflect the sunlight for about 1 to 3 years. This could make the sky whiter and more reflective, the way it is days after a volcano outbreak. But not only that.
There's evidence from basically every single climate model that shows that if you do a pretty even north to south, east to west distribution of aerosols in the stratosphere, you could reduce many of the most important climate hazards. So changes in water availability, changes in temperatures, including extreme temperatures. And there's evidence that that would protect or reduce the risk from some of the people most at risk in the planet.
To cool the planet permanently, aerosols would have to be injected into the atmosphere over decades and across large areas. Balloons, artillery, airplanes, and even towers could all potentially be used to get the aerosols into the air. Sounds like a lot of effort and money? Well, to lower the temperature with this technology by 1 degree, we'd have to spend an estimated $18 billion per year. To put that in perspective, in 2018, the emission-heavy oil and gas industry in the US alone saw a revenue of $180 billion. And natural catastrophes around the world resulted in damages to the tune of $210 billion in 2020 alone. Due to climate change, they've become more intense and more costly. But the potential advantages could come at another price.
Es gibt eben Befürchtungen, dass der Einsatz von Solar Radiation Management, also von diesen Geoengineering-Maßnahmen, zum Beispiel Niederschlagsmuster verändern kann, Wolkenbildung verändern kann.
This is Barbara Unmüßig, co-president of the German Green Party's Heinrich Böll Foundation. She has her doubts about scientists conducting further research into stratospheric aerosol injection.
Und das ist aus unserer Sicht, sind es Risiken, die nicht kalkulierbar sind.
One study from 2009 suggests that a small potential of acid rain could fall in some regions. Others see a risk of damages to the ozone layer and even more weather extremes, arguing that releasing aerosols in just the northern hemisphere could lead to reduced rainfall in India and the African Sahel. Even if it did work out in the end, critics like Unmüßig see the risk of misuse of the method as a climate weapon, potentially resulting in violent conflict.
Das ist wie mit der Kerntechnologie, Atomkraft. Da hat man auch gesagt, wir müssen forschen und hat überhaupt nicht bedacht, was es für Langzeitwirkungen hat.
So far, almost no field experiments have been done. This year, the research project SCOPEX aimed to conduct an experiment with a balloon flight in the atmosphere above Sweden to assess the effects and the risks of solar geoengineering. The program was funded with the support of many donors, including none other than Bill Gates. But the Swedish Space Corporation cancelled the test at the last minute after protests from environmentalists, including from the Heinrich Böll Foundation and local communities. But there are also other ideas out there. Could you imagine bubbles like this or this helping to cool the planet? The ocean covers more than 70% of the planet. Dark blue water reflects very little sunlight and absorbs more heat. The brighter a surface, the more radiation is reflected and the less it heats up. This is called the Albedo Effect.
The idea of micro bubbles in the ocean is making a foam to reflect away some portion of incoming solar radiation and to deploy it in strategic locations where you could possibly effectuate certain climate outcomes.
This is Dr. Corey Gabriel, a climate scientist at San Diego University, California. He has modeled the regional effects of ocean foaming. In theory, this foam could reflect 10 times more sunlight than the water and could cool the planet by more than 0.5 degrees Celsius if well distributed. But how exactly is it supposed to work? Scientists have suggested using special ships to churn up foam in their wake. Or it could be done by the global trading vessels fleet already plying the oceans. Sounds unbelievable. And there are more question marks. Bubbles burst after mere seconds. To reflect enough sun, they'd have to stay on the ocean's surface for days. Chemicals to extend the bubble's lifetime might be an answer, but the potential effects on the marine ecosystem of covering large areas with artificial foam haven't been explored. Then there are the costs.
The microbubble technology is very early stage and also potentially kind of dangerous in terms of deployment.
The impact on weather patterns could be huge and hard to control. Gabriel has modeled the effects if ocean gyres in the southern hemisphere were made significantly brighter.
It rains more in India and parts of Africa, but you end up with a very, very onerous drought situation in certain parts of the South Pacific. So you create all sorts of terrible problems for people who have already really suffered with climate change.
To make this a realistic approach, much more research needs to be done. Were the results to be encouraging and the method shown to be safe, Gabriel could rather see it being used in regions where dramatic climate emergencies are already underway.
So what concerns me with this is that there are unequal regional benefits and that somebody could get the idea that, oh, we want it to rain far more in country X, or we want it to be way cooler than it is in country X. We don't care about country Y, so we're going to impose this.
Let's move to something less threatening and more practical. During summer, many cities get hot, really hot. New York, for example, is on average 1 to 3 degrees Celsius warmer than its surroundings. On some evenings, even up to 12 degrees. The reason? Less reflective dark roofs, streets, highways and pavements heat up more than trees, fields and places with vegetation that has shading effects. But we already have a solution to that. Traditional architecture in African, Arab and Southern European countries like Greece. Solutions that could actually work for 4 billion people living in urban areas around the globe. Simply painting houses and roofs white can cool them. It's relatively easy, cheap and it works.
Basically, local temperatures could be decreased by something of the order of 1 degree, more or less. And obviously, this is an average number for very hot days where you would have a lot of radiation. The effect could be even higher. So yes, it can help, definitely.
This is Professor Sonja Senerivatne. She investigates the albedo effect in cities and in the countryside. The New York Cool Roof program was launched in 2009 by the New York City Service and Department of Buildings. The roof temperature here sank from 168 degrees Fahrenheit to 119 degrees Fahrenheit, a 30% reduction. Since then, about 1 million square meters of roofs have been painted white. Making all US roofs more reflective could save $1 billion by using less energy. there'd be less need for air conditioning for a start. If roofs and pavements were to have a higher albedo globally, the benefits would roughly amount to offsetting the greenhouse emissions of 700 mid-sized coal power plants. The approach only works locally. It doesn't impact the global climate. But everybody can do it, and the best part? No side effects. Even greater effects could be achieved if we could brighten up land areas. One idea is to plant brighter crops or genetically modify their color. But of course, that's extremely controversial and a whole new can of worms. Another way is called no-till farming.
If you do no-till farming, you basically leave crop residues on the soil after harvest. And this means instead of having the dark soil that is exposed, you have those crop residues on top of the soil, and those residues are a bit lighter.
Her studies show if this method were introduced in large areas, for example Europe, there could be a cooling effect of 1 degree Celsius or more, especially in the hot season, and could help to prevent soil erosion and droughts by keeping soil moist. But making a switch to no-till farming would entail lower harvest yields than in conventional farming for some time, and no-tilled fields are considered more vulnerable to pests. Reflecting cities and crops is a way to adapt to climate change, but it only cools down local areas and doesn't influence the climate overall. Stratospheric aerosol injection is still just an hypothesis. It could work globally, in theory. Due to many unanswered questions and a never-ending list of potential risks, it is a long way off from being implemented. In terms of feasibility, research data and risk assessment, ocean forming seems to be even a less realistic approach. So, solar geoengineering, yes or no? An additional way to mitigate climate change or a dead end? It is literally a hot topic, and scientists are split on whether we should do more research or not.
If we don't do the research, then the next generation will have to make decisions in ignorance. And they may end up making decisions to try implementing this, even without research. But I think that would be foolish, and I think there's somewhat of an ethical imperative to provide information to the next generation.
Many scientists might not be of the same opinion, but the vast majority agree on this point. Brighter skies and brighter oceans don't change the fact that we have a responsibility to cut emissions quickly, and that we need to find ways of adapting to climate change.